At transformer boundaries, plates slide past each other. Friction builds. Movement suddenly occurs, and earthquake waves spread through the crust.
Glaciers and glacial landforms. Glacial erosion landforms 1. Glaciers carve valleys and hollows. They form U-shaped valleys, widened river valleys, and cirques, bowl-shaped depressions at a glacier's head. Glaciers create striking erosional landforms in mountains. As a glacier flows down a former river valley, it widens and deepens it into a broad U-shaped valley, unlike the V shape cut by rivers. At the very head of a glacier, the ice scoops out a bowl-shaped hollow called a cirque.
Glacial erosion landforms 2. Sharp ridges, hanging valleys, and fjords. Aretes are sharp ridges between valleys. Hanging valleys form where small glaciers meet larger ones. Fjords are deep, narrow inlets where the sea floods glacial valleys. Glacial erosion also produces sharp, dramatic features. An arete is a knife-edged ridge left between two glaciers or cirques that erode side by side. A hanging valley forms where a small tributary glacier's valley is left high above the main U-shaped valley. A fjord is a deep, narrow coastal inlet created when the sea floods a glacial valley.
Glacial landforms. Importance. They serve tourism, harbors, farming, and water. U-shaped valleys and cirques attract trekking/skiing. Fjords aid harbors and fishing. Glacial soil supports farming. Glaciers feed rivers with fresh water. Glacial landforms matter to humans in several ways. U-shaped valleys and cirques become tourist spots for trekking, skiing, and mountaineering. Fjords make excellent natural harbors and fishing grounds. Some glacial valleys have fertile soil for farming. And the glaciers themselves are vital stores of fresh water that feed the rivers millions of people depend on.
Moraines. What they are? Deposits left behind by glaciers. Made of rocks, soil, and debris called till, deposited when a glacier melts. Figure 2.19. Moraines are depositional glacial landforms, ridges or mounds of rock, soil, and debris, together called till, that a glacier carries along and then leaves behind. Figure 2.19. They form mainly when a glacier melts and dumps the material it had been transporting.
Types of moraines. Lateral, terminal, and medial. Lateral form along glacier sides. Terminal mark the glacier's furthest advance. Medial form where two glaciers meet and their lateral moraines join. There are three main types of moraine named by where they form. Lateral moraines build up along the two sides of a glacier. A terminal end moraine forms at the glacier's snout and marks the furthest point it advanced. And a medial moraine forms down the middle when two glaciers merge and their inner lateral moraines join together.
Moraines. Importance. Useful for soil and water. They create fertile soil and can form natural dams and lakes for water supply, irrigation, and hydroelectric power. Moraines are useful to people because the fine material in them often makes fertile soil for farming. Moraines can also block valleys to create natural dams and lakes, and this stored water is then used for water supply, irrigation, and sometimes hydroelectric power.
Wind and its landforms. Wind erosion landforms 1. Wind carves and polishes rock. Yardangs are streamlined rock ridges carved by wind. Ventifacts are rocks polished and shaped by sandblasting. Figure 2.21. Wind creates distinctive landforms through erosion in deserts. A yardang is a streamlined ridge of rock carved when wind, armed with sand, wears away the softer rock and leaves the harder rock standing in long ridges. Figure 2.21. A ventifact is a stone that has been smoothed, polished, and shaped by the natural sandblasting action of wind-blown sand.
Wind erosion landforms 2. Wind scoops and flattens land. Deflation hollows/blowouts are shallow depressions where loose material is removed. Desert pavements are flat surfaces left after fine particles blow away. Wind also lowers and flattens the land. A deflation hollow or blowout is a shallow depression scooped out where the wind removes loose sand and dust. A desert pavement is a flat surface of tightly packed pebbles left behind after the wind has blown away all the fine particles, leaving only the coarse ones. In depth. An oasis, figure 2.22, can appear in a deflation hollow where the water table is reached.
Dunes. What they are. Hills or ridges of wind-blown sand, found in deserts or along sandy coasts. Figure 2.23. Dunes are hills or ridges of sand piled up by the wind. They form in deserts and along sandy coasts wherever there is loose sand and wind to move it. Figure 2.23. Their shape depends on how much sand is available and on the direction and strength of the wind.
Types of dunes. Birchen, longitudinal, star, and parabolic. Birchen equals crescent-shaped, one wind direction. Longitudinal equals long ridges parallel to wind. Star equals many arms, winds from many directions. Parabolic equals U-shaped, often stabilized by vegetation. There are several types of dune. Birchen dunes are crescent-shaped and form where sand is limited and the wind blows from a single direction. Longitudinal dunes are long ridges lying parallel to the wind. Star dunes have several arms and form where winds come from many directions. Parabolic dunes are U-shaped and are often anchored in place by patches of vegetation.
Dunes. Importance. Dunes protect and provide. They act as barriers against desertification and wind erosion, support tourism and adventure sports, shield coastal settlements, and supply sand for construction. Dunes are valuable to people. They act as natural barriers that slow desertification and protect land from wind erosion. They offer sites for tourism and adventure sports. Along coasts, they shield settlements from strong sea winds and waves. And the sand from dunes is sometimes used in construction.
Underground water and its landforms. Karst topography. Groundwater creates unique landforms. In limestone or soluble rock areas, chemical weathering and erosion form karst topography. Underground groundwater shapes the land where the rock is soluble, such as limestone. As slightly acidic water seeps through, it slowly dissolves the rock by chemical weathering, creating a special kind of scenery known as karst topography, full of caves, sinkholes, and underground channels.
Caves, stalactites, stalagmites. Features formed inside caves. Caves equals hollows dissolved by acidic water. Stalactites hang from the ceiling. Stalagmites rise from the floor. Figure 2.24. Inside limestone regions, groundwater creates several cave features. Figure 2.24. Caves are large hollow spaces dissolved out of the rock by acidic water. Within them, dripping mineral-rich water slowly builds stalactites, which hang down from the ceiling like stone icicles, and stalagmites, which grow upward from the floor. Tip to remember: stalactites hold tight to the top.
Sinkholes and underground rivers. Drowned collapses and hidden rivers form. Sinkholes, dolines, form when drowned collapses into an underground cavity. Figure 2.25. Underground rivers flow through cave systems. Figure 2.26. Groundwater also produces surface and hidden features. A sinkhole or doline is a depression or hole formed when the ground collapses into a cavity that water has dissolved beneath it. Figure 2.25. Underground rivers are streams that flow through cave systems below the surface. Figure 2.26. Carved out by the same slow dissolving action.
Underground water. Importance. Valuable for water, tourism, and study. Caves and underground rivers give fresh water, tourism, and cultural/religious significance. Stalactites and stalagmites attract geologists and adventurers. These underground water landforms are useful to humans. Caves and underground rivers can supply fresh water and attract tourists, and many hold deep cultural or religious significance. Stalactites and stalagmites also draw geologists and adventurers, making such areas valuable for both study and recreation. Landforms and disasters. Disasters linked to landforms. Certain landforms bring certain disasters. The chapter highlights landslides, avalanches, GLOFs, and dust storms. Activity. List prone areas, mitigation measures, and recent examples. Different landforms are linked to different natural disasters because the same processes that shape the land can also endanger the people living on it. The chapter focuses on 4: landslides, avalanches, GLOFs, glacial lake outburst floods, and dust storms. For each, you're asked to note its prone areas, mitigation measures, and recent examples.
Landslides. Slopes become unstable and fail. Caused by heavy rainfall, water adds weight, cuts friction, earthquakes/volcanoes, steep slopes, loose rocks, and human actions, deforestation, mining, road/hillside construction, poor drainage. A landslide is the sudden downward sliding of rock, soil, and debris on a slope. Natural triggers include heavy continuous rainfall, water adds weight and reduces friction, earthquakes and volcanic eruptions that shake the ground, and steep slopes with loose rock. Human actions: deforestation, mining, road cutting, unplanned hillside construction, and poor drainage make slopes even more unstable.
Avalanches. Sudden collapse of snow on steep slopes. Caused by heavy snowfall, weak snow layers, sudden warming, melting reduces friction, strong winds, earthquakes, and human activities like skiing or trekking. An avalanche is a sudden slide of a large mass of snow down a steep mountain slope. It happens when the snowpack becomes unstable, from heavy snowfall adding weight, weak bonding between snow layers, a sudden temperature rise that melts and loosens the snow, or wind piling snow unevenly. Earthquakes, vibrations, and human activities like skiing or trekking can set it off.
GLOFs, Glacial Lake Outburst Floods. Sudden release of water from glacial lakes. Rapid glacier melting raises lake levels and pressures, ice/moraine dams. Heavy rain/snow, earthquakes, avalanches, or landslides can burst the dam, flooding downstream areas. A GLOF, Glacial Lake Outburst Flood, is the sudden release of a huge volume of water from a glacial lake. As glaciers melt faster with rising temperatures, these lakes grow and press against their natural ice or moraine dams. Heavy rain or snow, or a shock from an earthquake, avalanche, or landslide can burst the dam, sending destructive floods rushing downstream.
Dust storms. Strong winds lift loose, dry soil and sand. Common in dry/semi-arid regions after drought. Sparse vegetation from deforestation, overgrazing, poor farming, and climate change increase their frequency and intensity. A dust storm occurs when strong winds lift large amounts of loose, dry soil and sand into the air. They are common in deserts and semi-arid regions after long droughts, when the soil is dry and there's little vegetation to hold it. Often worsened by deforestation, overgrazing, and poor farming. Climate change and extreme weather are making them more frequent and intense.
Case notes: Chamoli and Baratang. Real Indian examples to explore. A devastating flood hit Chamoli, Uttarakhand in February 2021. Lives lost, roads, bridges, hydel projects damaged. Also, India's only mud volcano at Baratang, Andaman and Nicobar, bubbles mud from underground gases and pressure, a rare natural wonder. Two real Indian cases bring these ideas to life. In February 2021, a devastating flood struck Chamoli in Uttarakhand, killing people and livestock and destroying roads, bridges, and hydel projects, a disaster linked to fragile mountain landforms. In contrast, the Baratang mud volcano in the Andaman and Nicobar Islands is India's only mud volcano, a rare natural wonder where mud bubbles up from underground gases and pressure.
Plate boundaries are places where plates meet. Some collide, some separate, and some slide past each other, creating new landforms and earthquakes. When continental plates collide, rock layers are squeezed and lifted. Over time, this forms great fold mountains, such as the Himalaya.